Hi everyone, this is Shivam. Imagine two teams. Both deploy an app called web app. Same name, same cluster. What happens? Does one override the other? In real company, that would be chaos. So, how do big teams avoid this? And by the way, this is the final video of my series How Kubernetes Thinks. We have looked at how Kubernetes reacts, how pod starts, and how labels connect everything. Now let's see how companies actually organize all this. Most beginner thinks one cluster, one application. But that's not how companies run Kubernetes. They run dozens of apps in one cluster. So how do they isolate things without buying 20 clusters? Let's simulate that chaos first. So here I am in my cluster and we can see I have already created a deploy.yaml file and one svc.yaml file. Let's first check the contents of deploy.yaml file. We can clearly see the kind is deployment. The name of the deployment is my test deploy. The label, what it is using is app equal to my test deploy. It has two replicas and it is using an nginx image. So let's go ahead and apply this deployment. Our deployment got created and we can see we have two pods up and running. Now let's pretend another team deploys the same app with the same name. If two teams use the same deployment name in the same namespace, they collide. For example, suppose another team deploys this same deploy file but with a Redis image. Imagine that scenario where this deployment with nginx image gets replaced with the same deployment name but with a Redis image. That would be disaster for a company. And this doesn't scale in companies. To tackle such kind of issues, Kubernetes provides something called namespaces. A namespace is just a logical partition inside the same cluster. Let's try to see what all namespace do I have in my current cluster. By the way, you can either use ns, which is shorthand for namespace, or you can type namespace fully. So as we can see, I have multiple namespace like dev, production, staging, team A, team B, and there is one default namespace. Now let's try to apply the same deploy file, what we have created in the default namespace, into team A and team B namespace. We can see our deployment got created. Let's try to get those deployment in different namespaces. We can clearly see that both the deployments have exactly same name, but they were created in different namespaces. So same deployment name, same app, no conflict. Now let's try to prove the isolation. If I try to run kubectl deploy without specifying any namespace, I will see all the deployment in the default namespace. However, if I run the same command with option -a, then it will give me all the deployments in all the namespaces. We can clearly see our default namespace has a deployment called myTestDeploy with two replicas. Similarly, team A namespace has a deployment named myTestDeploy again with two replicas, and similarly team B have the same deployment name again with two replicas. So everything is separated logically. Here I have created a sample service. Let's go and explore this. So as we can see, the name of the service is myTestService and it is using a selector app equal to myTestDeploy, which will be used by the service to connect to our pods. So let's go ahead and apply these services in team A namespace and team B namespace. Both our service got created. Let's go ahead and check them. We can clearly see that our service is created in both the namespaces. So same service name, still no conflict. Now let's go ahead and verify the endpoints of each of these services. We can see here there are two endpoints for this service. And if you look at this tab where I have two pods from team A namespace, and if you check this IP addresses, you will see that this endpoint IP address and these pod IP addresses are same. So this confirms that our service in team A namespace was connected to the pods in team A namespace. Similarly, let's go ahead and verify the endpoints in team B namespace. And here also I'll get the pods in team B namespace. Again, check these endpoints. These IP addresses are nothing but the pod IP address in the team B namespace. If you see here, these are the IP addresses. So this clearly explains the isolation using namespace. Even though the name of the deployments are same, the name of the services are same, but still there is no conflict, and this is possible only due to namespaces. In companies, namespaces are used for different teams, different environments like dev, production, staging, UAT, and QA, and for different projects. They share the same cluster infrastructure, but logically they are isolated. Without namespaces, teams would override each other's deployments. Services would clash, resources would become impossible to manage. Namespaces give structure without extra hardware. So now think about this. One cluster, 20 apps, 5 different teams, multiple environments, and it all works because of logical separation. This is when Kubernetes starts looking like something built for companies and not just for labs. So now you understand how big team runs multiple apps in one cluster. Same names, same infrastructure, no chaos. But here's the uncomfortable truth. Just because everything is organized, that doesn't mean it's safe. What happens if one application consumes all the CPUs? What happens if traffic keeps going to the broken app? What happens if a bad deployment hits production? That's exactly what we are starting next. A new series called Kubernetes Production Survival Guide, focused on stability, survival, and production safety. Because in Kubernetes, things will go wrong, and you need to know how to survive it. That's it for this video. Now you understand how this actually works in production environment. I will see you in the next one. Till then, keep learning.